This video is going to explain good ways and bad ways of learning times tables. First of all, it's quite common to find lots of children who can count in various different numbers. For example, most children can count in twos, they say 2, 4, 6, 8 and so on. Some children count in threes, they'll be able to say 3, 6, 9, 12 and carry on and so on. And as the numbers get larger, correspondingly smaller numbers of children can actually count on in those numbers. But counting on in numbers is not the same as knowing your times tables. And that's an important thing because a lot of people think that it's the same thing. It's not. If you know your times tables, then you know the facts both ways. So for example, you might know that if you've got let's ignore this for a moment. If we've got 5 times 7, then you've got 35. And someone who really knows their times table can be given the number 35, and when they hear the number 35, they think of 5 times 7. Someone who counts on won't know it this way. They'll be able to work out that 5 times 7 is 35, usually by counting on in their fingers, but if they get told 35, they won't have any immediate way of getting back again. And that's not so much a problem with the 5 times table, but if, for example, you were to get given a number like 63, someone who knows their times tables would think, okay, that's 9 times 7. Someone who doesn't know their times tables wouldn't have a clue. So, how do you learn your times tables? Well, a good way of doing it is to use flip cards. It's old-fashioned, but it works really well. And what you do is you have a pile of times table cards, like I've got in front of me, and you go through them. And you look at it, and in your head you say, okay, 6 times 7, and you have a guess at the answer. If you don't know the answer, you put it on the I don't know them cards. So 6 times 7 is 42. So there's the I don't know card. And you have a look at it, and you have a think 6, 7 to 42, and you say it to yourself a few times. And then you have a go at the next one, 8 times 7. Okay, I know that one is 56. So you check yourself, yes, it's 56, so you put that on the I know the answer pile. 7 times 7, okay, that's 49, I know that one. So put that on the I know them pile. 5 times 7, oh, I'm not sure about that one, no, I don't know it. Okay, it's 35, put it on the I don't know it pile. So, what you're looking for is the times tables that you know pretty much straight away, that's this lot over here, and the times tables that you don't know straight away, that you had to think. And with a child, it's important to watch them when they do this, because if a child takes a bit more than a few seconds to get the answer, then they're almost certainly counting on in their heads, and they don't really know it. So that times table card needs to go on the I don't know it pile. So, you review the ones you don't know. Okay, 6 7s are 42, 5 7s are 35, and when you've reviewed them, you shuffle them up and you go through them again, and you say to yourself 6 7s, oh, I think I know that one, that's 42, yep, okay, so I've got that one, so you put it on the I know it pile. 5 7s, no, can't remember it, put it on the I don't know it pile. And you repeat that a few times until you've got them all. And if you do that every day, and you pick one times table, and you do that exact process, you will find that pretty soon you start to get a feel for the numbers. So 6 7s, you'll find the person who knows 6 7s will be sitting there thinking, oh, it's 40 something. Okay, it's 42, and you'll learn them. So that's a good thing to actually know. Now, why do we want children to know their times tables, their number facts? It's because it speeds them up with the harder stuff. Things to do with fractions and percentages and all the other maths you do. If you have to work out your times tables every time because you don't know them, you're a little bit like someone who has to look up every word they spell in a dictionary. It just slows you down so much that you really lose your train of thought. You don't know what you're doing. Now, it is true that you don't need to learn them all, but that's a pretty bad place to start from. I'll give you an example, though. It's a sign of a strong mathematician and someone who's getting good at numbers is someone who can use number facts to work out other number facts. For example, that person might know that 3 times 7 is 21, in which case 6 times 7, so you've got twice as many 7s, is 42, and they'll notice things about the numbers. But somebody who's noticing these sorts of things about the numbers is almost certainly going to start to remember the 42. So there's a sort of a crossover here. Good mathematicians, people who get better at numbers, they start by learning about the numbers, and then they notice the patterns. For example, You might have, I don't know, 2 times 8 is 16. Well, if you double that, you get 4 times 8, which is 32. And you might notice that if you double 6, you get 12. That's why there's a 2 on the end. And of course, if you know 4 times 8, then 8 times 8 is pretty easy. It's 64, because it's just doubled. There's 4 8s here and there's 8 8s here. There's another 4 8s. But then you might already know this one because you might know your square numbers. So somebody who started to learn the facts will learn more facts quicker. It's a bit like a sort of a chain reaction. But if you don't know your facts, it's going to slow you down. And certainly if your child is someone who sees themselves as struggling with maths, then you certainly want to get them doing their times tables on a daily basis until they know their times tables. It's very, very achievable. But the person who's in the best place to achieve that is the parent. It's a gift you can give to your child.